All right, let's finish this up. So here's a correct interpretation of the interval, the confidence interval. So we will include these numbers. Okay, so we're 90% confident that wait a minute. This says a female. I don't like that. Okie dokie. That this should be that the average number, So this should be, I'm 90% confident that the average number of miles driven annually is between 16 or for the I don't like that right there. So that's a no-go. I'm going to have to say that. So this is out, and then 90% of the time, that's also no-go. Okay. But look at A and B. Let's check and see which of those two we like the best. So 90% probability that the true mean is between those two things. B says 90% of all female drivers are going to, that's kind of like C saying, so between A and B, again, this is putting like all other all other females. So this is still about all other female drivers, not the average 90% of drive between this. Okay, so that's saying 10% of them drive something else, a different amount. So that's really not what an interval is interpreting, that 90% of all females do what's between your interval, and then the other 10% do something else. No. Intervals are about the average of all of them. So I'm 90% confident that the true average miles driven annually for all females is between this and this. Now, I personally don't like this 90% probability, okay? But of all of these answer choices, that one is the best. And this one, E says, in repeating samplings, the average number of miles driven by females would be within 90% of the time. That means the average is going to be somewhere else 10% of the time. Okay, so we're going with A, the lesser of the evils. I don't like that 90% probability, but the other ones definitely have problems with them. All right, so number 24, consider these results. Let's see. So there is enough evidence to reject the null. So if I'm rejecting the null and this is an error, then I should not have rejected it. That means HO is true. That's type 1 error. So if the null is really true, but we get a sample that causes us to reject the null, that's a type 1 error. Okay, so power. Power is the probability of determining that there's an effect, detecting an effect. Power is rejecting the null hypothesis because it is false. Power is detecting something else is happening because it really is. Power is a good thing. Power is not an error. So if you have answer choices that are errors, you can automatically knock those out. Power is not saying the null is true because it really is true. So this is what A says. It says null is true. But we want to detect if bifocals slow the rate, work better when they actually do work better. And that's what D says. Probability of detecting bifocals work better when they do work better. Okay. And the last one, number 26, we had a problem here where we were wanting to do a hypothesis test because we were wanting to investigate and see if there is convincing evidence of a change. And the data is quantitative because it is their blood pressure. So we're measuring their blood pressure. And it was in one sample of men where we get 2 readings from them. So they were matched pairs readings for the difference in there. Okay, so all for that. But that was a really important first problem, kind of working through that one that I had initially gotten a wrong answer on. So I'm glad that I caught it and fixed that for us. And so I'll go fix that on the answer key.